Hey everyone, Shashank this side. I hope you all are doing well today. So today we're going to check how to configure a failover with RDS. So basically what we're gonna do, we're gonna perform a multi-AG deployment, multiple availability zone deployment with RDS. And we're gonna check how to configure the failover cluster over there. So basically it's kind of a master slave combination where master can be in one availability zone and slave can be in a different availability zone. So this is quite important to understand. Reason being, let's say we have to do some kind of a maintenance in terms of patching or a hardware upgrade on the database side without impacting the actual prod customers, or in case of a server failure or a hardware failure, then with the help of failover cluster and multi-agent deployment, we can make sure that our application will be up and running across 24 cross 7 cross 365 days without impacting the actual production customers. So that's how this is quite important. So I have jotted down few points regarding multi-agent deployment and how to configure the failover, what are the benefits and what can be a failover condition before going into a practical demo session. So let's review this first and then we'll jump to our AWS Management Console to perform the demo. So Amazon RDS multi-AJ deployment. So when I say multi-AJ, it's multiple availability zone. So multi-AJ deployments provides an enhanced availability, durability of your RDS instances, making them natural fit for your production database workloads. So again, if you have a multiple availability zone deployments or multiple AZ feature is deployed across your RDS instances, then that will give you a better performance as well as the availability that what we require for any production workloads. So we can, as I said, we can make sure our application is up and running all the time. That's what every customer wants. Without any performance issues, we need to have our environment into a high availability zone. So when you provision multi-AG DB instance, Amazon RDS automatically creates a primary DB instance and synchronously replicates the data to the standby instance in a different availability zone. So as I said, this is kind of a master slave combination where the primary database instance where our application is getting connected all the time, but in background what RDS will gonna do, that will gonna synchronously replicates the data from primary database instance to the standby instance. So whenever failover happens, either you do it automatically or do it manually, then the standby instance should have the same set of data that is present with my primary instance. So that's how beautiful this feature is all about. Each AG runs on its own physical distinct, independent infrastructure and engineered to be highly reliable. So the benefits that we are getting over here is it's highly durable in nature, 24 cross 7 cross 365 available in nature. Then protection on your database performance as well. What does that mean? Unlike single AZ deployments, IO activity is not suspended on your primary during the backup. For multiple AZ deployments for MySQL, MariaDB, Oracle, PostgreSQL engines, because the backup is taken from the standby. Okay. However, the note over here is like you may still experience an elevated latencies for few minutes during the backup for the multi-agent deployments. So again, your application will be kept as highly available to the clients, but during the backup time, as this particular note says that the backup happens or taken by the standby instance, so obviously there will be a bit of latency during the backup time. So generally what backup duration we defined is like during Sundays, right? Every weekend once a full backup needs to be done for every databases. That's the ideal standard, or that can vary from organization to organization, but the standard is per week full deployment full backup should happen for the database. So that's what protection of your database performance is all about. Second, and the last one is automatic failover. So no manual intervention is required. So let's say if you're doing any kind of maintenance or there is a availability zone crash happened with AWS, or your compute unit got failed altogether, storage failure happens, what RDS will gonna do? That will gonna do a complete auto failover to the standby instance and make that instance as your primary instance. In that duration, you can work on the primary instance to get it fixed. So that's how the concept of RDS multi availability zone deployment has been created with a failover configuration as well. Failover concept is there as well. So for the production workloads, we should go for the multi-AJ deployments. We can do multi-region as well. That is for the disaster recovery. Multi-AG is again for the higher availability, because again, in this case, let's say if we are facing any issue with one of a region in Amazon where we have multiple availability zones, but if region is getting impacted, then obviously your application will get impacted, because Amazon, with one region, we have multiple data centers available in terms of availability zones. So if you go for the multi region deployment, that will gonna look in later videos. So that is especially for the disaster recovery. We should keep our DR servers in a different region altogether, like a different location altogether. So I hope this clears a lot in terms of the concept over here. So what I'm gonna do, I'm gonna jump to our AWS management console, because I have done few of the configuration already on the network side. I'm gonna show you that, and then we're gonna provision our EC2 instance that will get contacted to RDS. We have to provision RDS as well. So I'm gonna show you the configuration of multi-AG deployment as well. So let's jump to our AWS management console. So this is my AWS management console. I'm into RDS. So as you can see, I don't have any databases. So nothing is present over here. If we go to our instances, these are for the Ansible towers. So leave that. These are in stop state. We're gonna provision a new one. Then we have route table something. So I'll go to my VPC. I'm into Northern Virginia. Again, RDS is region specific. So if you are doing anything within Northern Virginia, that should stick to Northern Virginia until unless you open a communication with other region. So I have created a custom VPC called my VPC with CIDR range of 10.1.0.0.16. I have created three subnets. One is public, in which we're gonna provision our EC2 instance. Two are the private. So you can see the availability zone of these private subnets are 1B and 1A. So two different availability zone where we're gonna provision our RDS instances. I have created a route table as well. We have a public route associated with my public subnet. This is the public subnet, and the two private subnets. The two private subnets are associated with my private route. And there is an internet gateway created which is associated with my VPC, which is a custom one. So that's the only configuration that I have done. Another configuration that I have done is I have created what do you say, security group. Let's go to the security group. I have created a security group called RDS, which has connection opened for 3306 from the CIDR block for the VPC that we have, and SSH from my laptop machine. Okay, so let's go to instances. So first we'll go ahead and provision our RDS database. Before that, just wanted to show you another thing. In subnet group, I have created a DB subnet for HA failover, where I have added like two private subnets that we have created. This is one which is 10.1.32.28. This is subnet 2, and this is subnet 1. Nothing apart from that I have done in general. Okay, let's go to our dashboard. We're gonna create a database. So for that, click databases, create database, standard. As I said, we can select any one of it, but I prefer to use standard and define my own configuration. I'm gonna go with MySQL, one of my favorite. Then the same version. Now Last time with the last video that I have done with the creation of MySQL RDS database, that was the free tier where we haven't received any kind of a multi-AJ configuration. We can get the multi-AJ configuration with production and dev test. So I'm gonna go with dev test environment. Let's give this database name as, let's go cloud in techie way, something like that. Okay, so master username is admin. I'm gonna have auto-generated password. Now here we have three type of database sizes as present. One is standard, which include M series. Okay. Second is memory optimized, which includes R. So these are preferred instances. R and X are most preferred instance type that we have for the databases, because most of the databases are memory intensive. Okay, and third is the burstable classes, which is with T2 series. So I'm gonna go with T2 small, with so that I have to pay for small database, but still I'm gonna show you the costing for this. General purpose SSD 20 gigs is more than enough for me. Enable auto scaling for the storage, which is fine. Now here we have two options. Do not create standby instance or create a standby instance, recommended for the production usage. So create a standby in a different availability zone to provide data redundancy, eliminate the IO freezes, and minimize the latency spike during system backups. So as I said, these are the few general issues that we get with databases, like IO freezes, then the latency during the backups that happens on the production instances. So we just have to create a standby instance, and everything will going to happen. The backup happens on the standby instance. That is not going to touch the primary instance. Okay, we have to select our networking, which is my VPC. Then let's click on additional connectivity configuration. I have created a subnet, DB subnet, that I showed it to you. This is not publicly accessible, so I'm not going to do that. And RDS is my security group and the default instance that I have. So let's delete the default security group. I don't want that. Okay, so these are the additional configuration that we can do, like enable automatic backups, which I am going to disable it for now. Enable encryption, which is preferable as always. Enable advanced monitoring, enhanced monitoring, sorry. So all these comes with the costing. So that's why I'm going to remove all this for this particular video. Enable auto miner version upgrade. You can select this during maintenance. That will going to do it at background. So you can see like the costing for this particular instance is 51.94 USD. DB instance, the two that we have created, it's sorry, the one that we have created is costing for $24. Then the standby is again $24. Storage is quite less. In total, this is 51.94. So let's go ahead and create our database. Again, this will gonna take some time, so I'll gonna pause this video and resume it back once this is done. Okay, so my RDS instance is in modifying state. So if we go inside this RDS instance, what we are concerned about as of now is to get an endpoint so that we can check our connectivity from EC2 instance and the port, which is already there. Okay, so let's give some more time for this RDS instance to become an active available. Meanwhile, we're gonna create our EC2 instance. So for that, launch EC2 instance. I'm going with Amazon Linux with T2 Micro, always with low costing. Yep. So my VPC in a public subnet with public IP enabled. Rest is as default. So let's give this name as RDS. Select existing RDS, review and launch, Windows, launch an instance. Okay, so this is the RDS, this is the EC2 instance that is getting created. This is the public IP. So let's go ahead and open our terminal. Let's try to SSH into that. So my key is in download folder. Okay, so till the time this instance state is changed to running, we cannot log into our EC2 instance. Okay, so let's go to databases, refresh this. This still under modifying state, but we'll be able to connect it if every configuration that we have done in a proper way. You can see like region and multi AZ is 1A as of now. So we're gonna try to check whether our failover is working or not. So okay, let's try to connect this. I'll gonna grab this command, go to my window, enter. Yes, I want to connect. Here we go. So I'll gonna jump to my root and will install vm install MySQL just to run the command for MySQL for connectivity. Yes, so MySQL is installed. Let's clear it. So the command again for the connectivity with RDS instance of MySQL is mysql-h, then get the endpoint that what we have for RDS, this one, copy, where is that, paste, -u is your username, -p, enter. I have grabbed the random generated password over here, so let's try to paste, enter. Here we go. So we are able to connect to our RDS instance from our EC2 machine. So let's say show databases. So we have 4 default database. We're gonna try to create a new one, which is create database lgcticw, enter. Here we go. So we have our database created, which is this one. So as of now we don't have anything, so let's try to check if our failover is working or not. So for that, what we have to do, this is something I'll gonna discuss with you after the practical demo. Okay, so till the time our database is in the modifying state, we won't be able to do a failover, because for that I just want to show you like if you reboot then how the failover happens automatically. So again, let's copy this and try to, I'll come out of the database shell. We're gonna try to ping this. So you can see like we have 10.1.0.25 as the IP for the database endpoint that we have. So 11 packets transmitted, 0 received, 100% packet loss. So ping is not enabled over here and it's still under modifying state. Still we are able to connect because we have opened a connectivity from our security group, which is on 3306 port. So this will gonna take some time again. Once this status become available, then I'll gonna resume the video back again. Thanks. Okay, so RDS instance is available now. You can see the status has been changed from modifying to available. Okay, let's go inside this, and meanwhile, what I'll gonna do, I'll gonna use, sorry, first we have to connect. So I'll be creating a normal table consisting of a basic data, so that while it failovers to the other server, at least we're gonna check whether data has been replicated or not. Show, sorry, databases, use lgcticw. Okay, so I'm into a custom database that we have created, what we're gonna do, we're gonna create a table. Create table. I'm very bad at remembering and syntax, so sorry for that if I do some mistake. Let's say I'm going to create an admin table with name as varchar 30. Then we have let's say phone, again varchar, which is 10, and last we should be having email, again varchar 30. Guess that should be the last entry that I want to go with. So okay, so now insert into values, insert into which is admin table values, name is, let's say, me, then we have number, which is 678355667, so 3363910. Okay, and last we have email ID, which is, let's say, test@gmail.com. Enter. Done. So let's select star from admin. So we have a data over here, which is fine. Now let's go to our RDS instance. So I'm into my RDS instance, which is in availability zone 1A. So there is an option to reboot. So let's go ahead and reboot this instance. So let's say this particular availability zone goes down, sudden impact from AWS side, or some hardware failure happens, or somebody rebooted it, then what will gonna happen, right? So let's go ahead and reboot. This will gonna ask us for the reboot with failover or not. So we're gonna reboot with failover. Reboot the instance. So you can see like this is in the rebooting state. Now what we have to do, we're gonna check our ping. So let's get out of this instance. Ping. Let's go ahead and ping. So 10.10.25 was the IP before, 10.10.25. So this will gonna take some time again, because till the time it's in the rebooting state, we have to wait for that. So let's wait for a few seconds. Again, for your information, RDS instance creation takes around 5 to 10 minutes of time. So that much of time we have to wait till this becomes available. Okay, so you can see like security groups and everything is added. These are the inbound IPs, which is my CIDR block, and this is the outbound IP, which is open across all. Okay, now if you go to the configuration, these are the same thing that we have already seen with my last video. So if you are not aware of what RDS is all about, how to create RDS with MySQL or any other databases that it supports 6 different databases. So just watch my last video, that will give you a clearer understanding how this works. So you can see like multi-AZ is yes, that what we have created. So still in rebooting state, it's available now. So let's go ahead and try to ping this one. Now you can see like the zone has been changed. This is 10.10.42, which is in a different availability zone. So let's go ahead and check this. You see, this was 1A before, now this is 1B. So that means our configuration of multi-AZ deployment plus the failover is working fine from console point of view. Let's go ahead inside the database to check whether the data has been replicated properly or not. For that, we have to log into our RDS instance to connect to our RDS instance. Okay, so use LGCTICW, sorry, this is the database. Now select star from admin table, and here we go. Now the other instance is also having the same set of data. So the other instance, that what we called as a standby, is become active now after the reboot, and the 1A zone server becomes passive. So that's how the configuration works in terms of failover in RDS multi-AZ deployment. Again, I just as I showed to you the documentation that Amazon RDS provides for multi-AZ deployments, multi-region and RAID replica. So this is the table that is very important to go through it, because this is the place where you will gonna decide whether you have to really go with a high availability environment, or you want a disaster recovery as well. In a when then you will have to go with multi-region deployment, and we have something called RAID replica, which is for the scalability. So again, we have performed multi-AZ deployments. In next few videos, I'll gonna show you multi-region deployments and RAID replica, how to create it. So this is the table. As you can see, like multi-AZ deployments is main purpose is HA. Multi-region is main purpose is disaster recovery and local performance as well. Because let's say customer is from Europe and one customer is from US, and you have configured multi-region deployments for RDS, then obviously Europe guy will gonna hit the Europe server, the RDS part, and US will gonna hit the US server. So that means the performance latency will gonna get reduced a lot. Then RAID replica is a different concept altogether, which is mostly for scalability. For multi-AZ deployments, non-Aurora is synchronous replication. For Aurora database, which is Amazon database, that is asynchronous. We're gonna discuss this in later videos. Multi-region is a asynchronous deployment or replication. Same with RAID replica. Then for non-Aurora, only the primary instance is active. Aurora, all instances are active. That is called active deployment. So the configuration that we have done just now, this is considered as an active passive, but with Amazon Aurora it's active, which is again a good part. All regions are accessible and can be used for reads as well. All RAID replicas are accessible and can be used for read scaling. Then automated backups are taken from standby, but for Aurora, since this is an active deployment, then automated backups are taken from shared storage layer. Same with for multi-region, automated backups can be taken in each region. No backups configured by default for the RAID replica. Always span at least two availability zone with single region. That's the multi-AZ deployment. Each region has a multi-AZ deployment. So if you go with a multi-region deployment, in that as well you can have multi-AZ, so that you will gonna have a higher availability as well across the multiple region, and disaster recovery system as well in a different region. Can be within availability zone, cross AZ, or cross region as well. That is with the RAID replica. For non-Aurora databases, so when I say non-Aurora, these are MySQL databases, SQL servers, Oracle databases. So database engine version upgrades happen on primary. Aurora, it's happen together on both the instance. For non-Aurora databases in multi-region deployments, the database engine version is upgrade independent, obviously. For Aurora, it's together. Again, for non-Aurora, database engine version upgrade independent. So this is basically same across the board. Automatic failover to standby, and for or RAID replica, Aurora when problem is detected. Aurora allows promotion of a secondary region to be master. So we have that provision as well. You can make your secondary region instance as master, and can be manually promoted to a standalone database instance as well for non-Aurora, and primary instance for Aurora. So this is something very important documentation that we should go with while creating our RDS instances. So that will give you a clear picture which one we need to go for. Obviously multi-region deployment is always preferable if you have a budget. But if you don't have a budget, you don't want to go with higher costing, because you have, for multi-region you have to maintain two set of regions altogether. But for multi-AJ, obviously if you are having a budget issues, then within same region, multiple across the multiple availability zones, you can go with multi-AJ deployments. And replica is also there with an asynchronous replication. So that's it guys for this particular video. I'm gonna share this link with the description section as well. So just go ahead and try to configure your RDS instance multi-AJ deployments and try to configure the failover, because that's the best practices to make your application available all the time without any issues. So if you're facing any issue, just place out a comment in comment section and I'll be there to help you. Have a nice day. Bye-bye.